Quick review on simplifying and solving equations. You already know how to simplify and solve linear equations, meaning it's when you have the x to the first power. So it's still the same rules. Simplify both sides, isolate the variable, solve, and do the check step. So here's a particular equation or expression that they've given you. It's not in the normal form that you're accustomed to, but you still would follow the same procedures. You're going to simplify both sides first. Well, here they have a 2x times this binomial x plus 3. So you need to simplify the left side first. We'll distribute 2x times x is 2x squared, and then 2x times 3 is 6x. Simplify the other side. We're going to distribute. Take the x times the 2x and get 2x squared. X times the 3 and get 3x. Take 1 times the 2x and get 2x. And 1 times the 3 and get 3. We need to, can we simplify again? Yes, these are like terms, so we can add them. When we add them, we get 5x. Bring everything else straight down. Nothing more to simplify here. All right, so now looking at it, we have done the first step. We have simplified both sides of the equation. Our next step is to isolate the variable. Well, you've been working with one variable with the x to the first power. If you notice here, we have an x squared and an x to the first. So we, in a sense, have two different situations, or we have a second degree function. But you're still going to, at this time, we're going to go ahead and do it the same way we would have done if there was just the x to the first power. We're going to isolate the variables. We're going to get all the variables on the left side and all the numbers on the right. So here they have 2x squared. I'm going to subtract 2x squared from both sides. Remember, whatever you do to one side, you have to do to the other to keep it balanced. So this becomes 0, but notice this also became 0, which leaves you now with 6x equals the 5x plus 3. Now you have a first degree. It's been reduced down to a first degree equation where the x is to the first power. So this is, you're familiar with this, and you should know how to work the problem. Now that you've got this first degree equation. Normally, when solving, when you have something that has the second degree equation, you're going to learn another way to solve for them. The only reason why they're giving you these is because they made sure that whatever you got here is when you subtract would give you 0 and would reduce down to a first degree equation. I believe the only reason why they put this section was just to give you more practice in simplifying and then solving and doing a check step. All right, so we still haven't isolated, right, the variable because we still have an x on either side. So I'm going to subtract 5x from both sides. This gives me 0, which leaves me 3. And 6x minus 5x is x. And now we have actually solved, right? We've isolated and we've solved the equation. We can do a check step if we so choose to. The check step would be taking your original problem that you started with, right? And then substitute in 3. So we have 2 times 3 and 3 plus 3. 3 plus 1, and 2 times 3 plus 3. This is going to give me 6. This is going to give me 6 inside. This is going to give me 36. This is going to give me 4. And here 2 times 3 is 6, and 6 plus 3 is 9, and 4 times 9 is 36. So it checks out. We'll do one more. And we did these in class. Like I said, this is just a quick review. Same thing, we're going to simplify first, so we're going to distribute. Take this x times everything, right? Times all three of these. So x times x is x cubed because x times x squared, excuse me, is x cubed. X times negative 2x is negative 2x squared. And x times 3 is 3x. 1 times x is x squared. And 1 times a negative 2x is a negative 2x. And 1 times 3 is 3. Now, this here is everything that's on the left side. Before I even consider simplifying the right side, let's see, can we simplify? Well, here we have a negative 2x right here, and we have an x squared. So we can combine them. They're like terms. We're going to end up here with x cubed, and then this is going to give me a negative x squared. And then here we have 3x minus 2x, which gives me 1x plus 3. So now this is all simplified. So that's the left side of the equation. Because of my video and my paper, I cannot do everything. Like I cannot go ahead and do this one over here. I don't have enough space. And unfortunately, the way that my phone videos, it doesn't allow it. So for right now, we're going to say this is our left side. So I'm going to take this right here. I'm going to move it down the right side of my equation. And I'm going to go ahead and do the right side. So x times x is, well, and I'm going to need space. So x times x is x cubed. X times negative 4x is negative 4x squared. And x times 6 is 6x. 3 times x squared is 3x squared. 3 times a negative 4x is a negative 12x. And 3 times 6 is 18. We can now simplify. Here we've got x cubed. And here's an x squared and here's an x squared. So minus 4x squared and a positive 3x squared gives me a negative x squared. And here's x to the first, x to the first. So 6x minus 12x is a negative 6x. Bring down your 18. So this is what I get when I simplify it on the right side. So now I'm going to take my left side and my right side, and I'm going to write it down here. X cubed minus x squared plus x plus 3. That's that one. Then I'm going to do this one. X cubed minus x squared minus 6x plus 18. Now I've got everything back to where it needs to be. So we have now simplified the left side. We've simplified the right side. Now what we have to do is start isolating the variables, getting all the variables to one side. So if I subtract x cubed here, I have to subtract x cubed here, and that gives me 0. And this is a negative x squared. If I add x squared here, I have to add x squared here. Well, that happens to turn out to be 0 too. Like I said, they gave you a special, they particularly chose these problems so that your x cubed and your x squared would cancel out and reduce to a linear equation. So I'm going to go ahead and bring what I have left over here. I have x plus 3 equals minus 6x plus 18. Here's my linear equation. We're going to continue. We're going to add 6x to both sides. This is 0, so I'm left with 18. And x plus 6x gives me 7x plus 3. And now we are still isolating, right? We're solving. So we want to get x by itself. So we're going to subtract 3 from both sides. Here we get 15. This gives me 0. I'm left with 7x. Excuse me. Excuse me. Did I write something wrong? I want to make sure that I didn't write something wrong here. So x plus 3. This should have been a 4, and I don't know why. Let me just double check. I might have made a mistake here in writing my original problem down. X plus 1, x minus 2x plus 3. Oh, I did. My original problem had a plus 1 over here on the end. I apologize. So this should be 4. All right. So I'm now going to make this 4. I'm sorry. This is an example 6.13b. on page 215, so you can look at that. So this is 4. So I'm going to subtract 4 from both sides. So now instead of getting 15, I now have 14. Then we're going to divide both sides by 7. We get x equals 2. Again, you could take this and plug it into your original equation to do your check step. Okay? Sorry about that. When I first wrote it, I left off part of the original problem. But again, this is on page 215, example 6.13b.